let's discuss LeetCode problem number 1868. Find RLE product of two given vectors. Before we discuss, please share, like, subscribe, and hit on the bell button for notifications. Also, I have added a lot of LeetCode quizzes to the community page. It will give a different perspective on the LeetCode problems and help you prepare better for the interviews. Please check it out. Now back to the problem. We are given RLE basically stands for run length encoding, and so you are given, like in this case of like 1 3 and 2 3 is the first encoded vector, and then 6 3 and 3 3 are the second encoded vector. So it basically 1 3 expands to 3 1s. The first is the value, the first in the pair is the value, and second is the frequency of occurrence. And 2 3 expands to 2 2 2, 6 3 expands to 6 6 6, and then 3 3 expands to 3 3 3. So now you have to return the product, multiply. These things are equal, basically the number, the matrix, the size of the vectors are the same. So you have to multiply the corresponding numbers and then return the result in the encoded, once again the RLE format. So if you now multiply each one of them, it turns out to 6 sixes, and that's what you should return, 6 comma 6. That should be your output. Now I will show you with an example. Basically I have taken this example 2 3 3 3 and 2 2, and then 3 4 and then 2 4. So it is a little bit more complicated than the previous problem we discussed, where all the frequencies are the same. It's all threes, so it becomes easier there. So now if you see, this one expands to this one, so 2 3s. So you have 2 3s here, and then 3 3s, and then 2 2s here, and this one is 3 4 and 3 4. So it basically 8 threes, basically the second encoding. So now if you start off, you consider these two first, and then you multiply the first, because those are the values. So you multiply to get the 6. So because that's what it is, right? 2 and 3 you have to multiply here, and it becomes 6. Now you take the minimum of these two. So here we have 3 4s, and then we have only 2 3s here, right? So you have to consider this one first, because that is the value. If you consider the next one, the value will be 9 here, so you have to consider only the 6. So that's the reason why there is 1 3 remaining of the first 3. Let us so you take these threes against these 3 2s, and then get 6, and then there is still 1 remaining here, and that's what this is. So now because you exhausted the 2s, you move to the next one, 3 3s, which is this one. Now you start multiplying, because there is still 1 left in the second one, so you get the product as 9 and frequency as 1. And then the second one you exhausted. Now you move to encoding of 3 4, and then still 2 3s are remaining in the first one. So the next encoding will be 3 2 and then 3 4. Now your product is still 9, so you can still add them up, right? You can add them up to 9 comma 3 rather than having 9 1 and then 9 2. And then after that you basically do these two, and then it becomes 6 comma 2. So the answer is basically 6 3 9 3 and then 6 2. So now let's take a look at the code, how this one works. So let me clear off all the drawings. So now you take the resultant vector. I call this pattern as, if you see how it got implemented, the first product, the first items in the pairs you multiply, the second items in the pairs you subtract until 0, and so that's why I call this as first product second subtract until 0 pattern. And so you set I is the index for the encoding 1 and j is the index for encoding 2. M is the size of encoding 1 and n is the size of encoding 2. M and n may not be the same, but when you expand them out, that's when they become equal. So while I is less than m, j is less than n, you take the product of the first elements and then you take the minimum frequency as you saw in the example, and then this is the case where we saw that 9.1 and then 9.2, right? So if when the 9.1 is already in the result and if it is equals to the product, the second one the product is also 9, so you added 2 to 1 basically, so the frequency you add, so instead of 9.1 it became 9.3. Otherwise, you like in the case of 6.3 and then 9.1 and then 6.2, you come into this case and then add it to the resultant vector. Afterwards, once you're done, you do the subtractions here. Then whichever one reaches, if the encoding one reaches 0, then you increment the I to move the next element in the encoding 1. Otherwise, you do the increment the j and then you return the result. Hopefully this explains the problem. If you have any questions, please comment below. Otherwise, I will see you in the next video.